Hi, welcome back. We're going to now do 4 and 5 to finish out these multiple choice questions on comparing two populations or groups. And again, these questions are just proportion questions. So we're really focusing in on that. Okay, so as I read question 4, it says an ag researcher wants to see if a new fertilizer helps. So they look at 100 plants and they're looking at these in containers, two different groups. The plants are either sprayed or not sprayed. Now I actually think there's a little bit of a typo in here. They specifically call group 1. So here's some notes. Again, if you want to freeze the camera, take some notes and then re-listen at this point. Group 1 says no spray, but then they call that no spray 2. But then in the end, it looks like that's not what they're doing because their hunch is that the second one is bigger than the first. So again, if this was an AP test question, they would fix that. But okay, so looking at no spray, it looks as if the ones that get sprayed weekly, so it does look like the fertilizer's working because the ones that are sprayed weekly, which are in group 2, there's 18 out of 50, and that's the proportion, the sample proportion, and this is the other one. And so as I've collected the data here, they really want to know to determine whether or not they're the same. We assume they're the same. We assume that the fertilizer does nothing, that it's just like spraying nothing on there, right? And that's our only way to tell if it actually works, is to assume that it does nothing. That's our H sub O. And then our hunch is that the fertilized plants will grow more. So to do that, we're going to do our, hopefully everything that you've done in the chapter in this subsection is either a confidence test or a stat test, and we're going to do a 2 proportion Z, and I hit the wrong button, so you just go back and do it again. Stat test, 2 proportion Z. Okay, so now we see, oh, well, that's all my data here. In my first group, I had 12 out of 50, and in my second group, I had 18 out of 50. And looking at our data here, we do have a hunch that the second group has a higher percentage, right? 18 is more than 12. There it is. And we hit OK. Notice that I have a P1, a P2, P hat. That's kind of called the pooled data. We're going to talk about that in a minute. And there's my p-value. So they're really just asking you, what number is that? What number is the p-value? And notice we get 0.095. Well, that is in fact between those two numbers. So you might be thinking, well, why did they ask that? That's a really bizarre question. Well, back in the day of old people like me, you would only use the tables. And so the tables would merely put you in this range. You would not really know the exact p-value. You'd merely know whether or not you were in the range of p-values using a table. And all that really helps you to determine is if alpha was set at 0.05, then you did not have sufficient evidence. So you failed to reject the null. But if alpha was 0.10, in this instance, you would have sufficient evidence to suggest that the fertilizer is helping, right? So this is a rare outcome if this was your test of rareness, but not rare enough if that was your test of rareness because the p-value we got did fall between there. So again, just taking our notes, our p-value that we got on the calculator was right there. 0.095215. And that number does indeed fall between that number. Okay, last question. So question number 5, we're going to take some notes, and there's actually something really important I want to point out here. So make sure you're paying attention, and if you're not listening to the video, it's going to be hard because you're going to think one answer when it's the other. So the book actually has this answer, and I'm actually going to steer you here. Okay, so this would be if you pooled the samples together. So there's some specific facts in this scenario that might make someone think that they should pool the data. And I'm going to write right here on the sheet. And again, you can hand this sheet in, definitely hand this in and your notes. Staple those together, and that's what I'm looking for an assignment. You should pick this one. And I was in a training all the day to day, and another buddy of mine that teaches this class as well, he says, never get in the pool. Okay, so write that on your paper. It's very important. So it's like, why would the book have this? Well, in this instance, for whatever reason, they included this question, and it is correct, but the AP Stats exam limits all questions to not include pooled, specifically on our test. So if you actually took the class that goes after this class, so if you think of this class as Stats 101, you can take Stats 102 at college, and you'll get into why you might pool. But in this class specifically, don't get in the pool. So you would have, when you read a question like this, you should be thinking this, right? And because this matches our formulas that we've been using on your other notes. So again, this is your P1 and your complement of P1, your P2 and your complement of P2, and the N1 and the N2 that we talked about back on, right? Doesn't this look familiar? Now the only difference is this is the formula for so that was P1 and the complement over N1, P2 and the complement over N2. Instead of doing a confidence interval, you're going to calculate a test statistic in a test, and the test statistic will merely be the difference over the same standard deviation formula. So this is definitely your answer here. Okay, so never get into the pool. So think about maybe alligators are in the pool. You don't want to get in there, or maybe peas in the pool. Don't get in the pool. Whatever you do, don't get in the pool. So how would someone accidentally get in the pool, you're thinking to yourself? So if I had this data, and we should collect it in our notes here. Okay, so I have my males, right? And my group of males, they said 36 out of 40. And that's 0.8. And then I have my females. And that was 24 out of 40. Oh, excuse me, I have 45 males. And so that is my P hat. Then I can find the difference between the two, and I don't know if it matters here which one I call P1 and P2. I just need to keep straight. They said P1 is the males, so that sounds good. And they want us to do P1 minus P2, and the P2 is the females. And that would be there. And so when I subtract, I do get this number, and that is in fact inside all of these problems. The one that it's not inside is this one down here. See how that's really weird. Okay, so at that point, I've narrowed it down just to the top 4. Then we think about our N, right? This was 45, this was 40. And so we need to make sure we're looking for these numbers. You can also think about the complement of that would be 0.2, and the complement of that would be 0.4. So the formula that we need to calculate the test statistic would be this formula, unless we were pooling it. So this would be the formula that you should pick. So you're thinking, well, how would I pick it or not pick it? I've got to show you this on a calculator. So here we go. If I go to statistics, stat test. And I still am doing a 2 proportions z-test. They didn't even give me a choice. Okay, so our x1 was 0.8, x1 was 36 out of a total of 45 and 24 out of a total of 40. And we want to do one-sided, so that would be, I think P1 is smaller. So we actually think here that that would be a negative number, meaning the amount of men would be smaller. So I'm going to pick that one. This number is where that 706 is coming from. You see that? What they're doing there is they're combining it. So see that 706? That's not how we've been doing the problems on the other page. And so this would be the answer I'd like you to take. But I did want to kind of explain where those numbers would come from. Now the problem here, we know they're doing the same thing. And this one looks like they're doing a means question, not a proportion question. So they've used the wrong formula there. This is our choice. Thanks for joining us. Again, make sure you've taken these notes and bring them to class tomorrow. Hope you enjoyed your 3-day weekend. Take care.